Hi, everyone. First off, thank you for coming. Today, we're going to be going over 5G, but before we get started, I want to make sure that we have an opportunity to go over some introductions with everyone and make sure you have a general idea of what we're going to be discussing today. We're going to be doing kind of a high-level overview of what 5G is and why it's important to everyone. We're going to be talking about some of the challenges that it presents. Then we're actually going to go over the SIMULIA CST STUDIO Suite and what that product is and how it can help with 5G concerns. And then we're actually going to do a short product walkthrough. And then we're actually going to go and just kind of summarize everything and some key takeaways, and then we'll go from there. So starting off, I'm John Toes. I'm the Director of Product Strategy over here at Hawkridge Systems. Many of you know us as your SolidWorks provider. This is obviously the solutions that we provide at Hawkridge Systems. And you know, we span the gamut, everything from design software, software to manage your data, different types of simulation software, through manufacturing software. But many of you probably don't know that we also have a full range of hardware and services along with that. So all of our 3D printing and scanning technologies, as well as different types of services for all these different solutions that we offer here. Now, today we're going to be focusing on our simulation tools, specifically our SIMULIA CST tool. 5G obviously is, you know, a newer technology. Obviously, it's in the news a lot these days. But really, what does it come down to, right? And so at the end of the day, it really promises higher speeds and higher rates of data communication, you know, lower latencies, and really it allows the connection of multiple points of contact. And obviously that is going to enable all kinds of innovation. And this is just a snapshot of some of the different things that 5G is already playing a part in, but in the future is going to be playing a lot more of a role. What I will talk about here really quickly is my colleagues. So along with me today, I have Lou Feinstein, who is the Global Director for High Tech Industry at Dassault Systems. I have Mahesh Taranga, who is the Director of Business Development for Simulation. And I have Christopher Jones, who is a solutions consultant specific to electromagnetics and high tech in the automotive industry. So first off, I'm going to pass this off to Lou to cover a high-level overview of 5G and why it's important to you.
Hello, everybody, and thanks, John, for having us here today. So the first thing that we're going to talk about is really a hyper-connected world, and why is 5G so important? So when you look at things today and where we're heading in the future is the number of connected devices, and you see in the bottom here, we're seeing between 30 and 100x, are going to be in the 200 to 500 billion devices in the not too distant future. The next thing we're seeing is connection density. How many objects are in a square kilometer will exceed over 1 million. So we're really going to start taxing the systems that we have today, and we need to have much higher speeds to be able to provide data. So we're looking at data speeds exceeding 10 gigabits per second. And then the biggest thing is you can have the biggest and fastest and most robust network, but if the latency has to be less than 1 millisecond, otherwise you really don't take advantage of the capabilities of 5G. So when we talk about where are we heading, so let's take a look at some history here. So many years ago, we had mechanical systems. So you had mechanical systems and you put things together. Then we realized that, you know, basically we went into mechatronics. This is really exciting. We put systems engineering together. We've done multidisciplinary engineering. You've got electronics, software, and you really developed a system. Where we're heading to is what we're calling cyber-physical systems or cyber-physical experience. And this is where, you know, basically things become very software intensive, and it's a systems of systems. And basically your system that we would design as a mechatronic system is now interacting with the environment, such as you're seeing here, and such as in autonomous vehicles, where things now are talking to each other, and it becomes very much more complex. And the use of 5G is going to be the breakthrough that's necessary to make this happen. So when we really talk about 5G, it's really empowering customer experiences and innovations. And we see a lot of things that are very interesting here at Dassault, and everybody understands about connected automobiles and such. But what you're seeing is really where we're going to see a lot of new things is newer enhanced smart manufacturing. Wireless health is going to just go off. We're starting to see it now due to the pandemic. We're starting to see telemedicine, and you're starting to see data centers now shrinking in size and becoming more distributed. And then you're seeing antenna design becoming paramount into here, and then you're seeing media and data and connected things everywhere. So things that you never would think would be connected are become connected, and it's really changing the way the world is operating today. So when you really look at this thing, the real core to 5G and the technology is really antenna design for connected objects, because without antennas, you really can't communicate. So you think about it, it's really more complicated. And so today, we have 4 and 5G technology coming out, and you see, we're using existing frequencies, but we're changing into millimeter wave frequencies, which provides us a lot more bandwidth, but at a lower power density. And so it allows us to have a lot more channels, but you need to have a lot more capability to do this. And this is where we're starting to see smart homes and everything really taking off. So do you ever stop to think about how your cell phone connects you to your friends and family? It's magic, right? No, it's not. It's electromagnetic waves that are transmitted through the air and connecting you between the cell towers, the mobile device, your smart appliances, and anything in between. So anything that communicates today needs an antenna, and that is really why the focus of our session today is where we're really going to focus on the ability of CST and the development of antennas, because without antennas, 5G and all the smart appliances and things that are making our lives better just don't work. So when we talk about 5G and antennas, it's really 2 fields that we look at. And we really talk about the base stations. And this is really where we talk about the big systems, where we talk about the infrastructure. So we have what we call massive MMO structures, and we have what we call beamforming. So we can take these arrays and focus the beams into what we need to do. But there's the other side, is that basically you have the big infrastructure side, but now you need to have the same technology that works in your mobile device. So now what we're seeing is higher frequencies, larger of these MMO arrays with multiple frequencies. We're having a combination of digital and analog feeds, which is new to the system, and you have access to what we call to both front and back haul systems, which means that you have a lot more capability and a lot more needs. But the real key here is the ability to do beamforming and to have the proper antenna. So you can see that there's 2 skills to this. It's to build the massive antennas that allow you to communicate in a massive way, and then to build the antennas and the systems that allow you to communicate to those massive arrays. And when we talk about automotive, we see a lot of capabilities. So when you look at vehicles, everything is starting to be connected, and it's becoming interesting because connecting used to be very simple, as you put an antenna on the outside and things would work. But nowadays, the way the antennas are working, people want to be inside these objects that want to communicate also, is that it's really a complex and dynamic environment you're working in. And really what we're looking at is what will degrade or soil the antennas and sensors that you put in the systems. And so having technology such as a CST, it really allows us to do simulation to understand, how your platform or how your system is going to enable. And again, in automotive, it's going to be key. And anybody who understands who has a car today, there's so much technology in them, and it's continuing to evolve. So when you really look at a factory, what we're really talking about is the future of manufacturing, is where we're applying smart sensors and interconnects, antennas everywhere. And it really minimizes the infrastructure cost of factories, and it provides many key information things. So when we talk about smart, we really need to have antennas which act as the sensors. I mean, excuse me, you have devices and such as sensors. When we talk about connected, it means as soon as you hear the word connected, you have an antenna, and now you're dealing with wireless communications and such. So what is this really going to do in the manufacturing world? It's really going to change the manufacturing world quite a bit. So we'll be able to have interactive shop floor monitoring and live monitoring, meaning that all the systems, and you'll be able to have a view of a factory factory, and with one person controlling many, many aspects of it. Virtual commissioning, which is really important these days, it's the ability to set up a work cell or to set up the systems running without actually having hardware in place. Now, the next thing that we're seeing a lot of reaction to is augmented reality training. It costs a lot to build products, and to build the product in a virtual way is an interesting aspect. And one of the things that's really interesting that we've seen with some of our customers is the ability to place a bunch of parts on a table, and the augmented reality system will show a person how to collect, which part to collect, and how to put it together in an assembly, no matter what the part is using. And the last thing is that we're seeing a lot of interactions between humans and robots, and we call them, cobots and so forth. But to make that awareness real and to make sure that you don't have collisions between humans and robots, you need a lot of data collection. And we're seeing a lot of advances taking place because of the enablement and the large data streams that we can do with the 5G capabilities. And one thing that's really interesting, it comes out in the manufacturing world, is when you're putting these antennas out onto pieces of equipment, they can jam each other, so you really can't communicate. So one of the things that we're seeing now is not just the ability to understand where you're putting the antenna on the product to make sure that it doesn't self-jam, is to look at them in situ or in place inside a factory, inside a car, and to understand really where the best patterns are, where you're going to get the best communications. So it's now becoming more complex of equipment manufacturing and equipment placement in a factory, and really simulation is really going to be key. And now to talk about some of the business issues, I'm going to hand this over to Mahesh.
Thank you, Lou. So in this section, I'd like to talk about how simulation really helps in addressing some of the critical business issues ranging from reliability and safety. Lou has talked about a lot of the applications. So one of the things in recent days, like in 2010, some of us might remember iPhone 4 had an issue with dropped calls due to a new antenna concept. The resulting Antennagate was a huge problem for the image of Apple. Customers complained about dropped calls, and Consumer Reports would not recommend the phone. So it's a perfect illustration of why connectivity is so fundamentally important for a good user experience, especially when the entire purpose of the device is to connect you to the outside world. And in this case, the malfunction was significantly expensive. There was lost revenue in terms of lost units sold, and then also cost of bumpers to fix the issue, totaling about $475 million. All that because this little gap you see in the phone frame was not insulated properly. And this effect could easily have been predicted by a single quick electromagnetic simulation. In this case, Apple was obviously able to get through the crisis because it's a big company, but that would not be the case for any small company designing these devices. Compliance is probably the single most important requirement before any electronic device can go to market. In reality, almost 50% of the electronic products fail to meet the EMC requirements at their first test attempt. This is where virtual compliance evaluation using simulation comes into play. Many systems in close proximity can lead to increased interference problems if we don't take great care in the design. Physical EMC compliance testing, as you know, is very expensive, and failing tests is extremely expensive and time consuming. For example, diagnosis of the problem, redesigning to fix, retesting, all this basically puts a lot of pressure on the time to market, which really doesn't allow you any failure for you guys. So using simulation early and often to troubleshoot and propose robust solutions allows companies to pass their EMC tests at their first attempt. This is not to say that we are trying to replace testing, right? Measurement is really essential, but has major shortcoming. You can see that there is a problem, but you can't easily see what the source of the problem is. And for that, electromagnetic simulation really helps. Another important factor in the design of electronic devices is determining unwanted emissions. We need to make sure that the devices conform to the SAR standards, the specific absorption rate. This is where simulation for human exposure early in the design cycle comes into play and helps ensure certification success. Also, many times the actual physical testing itself uses things like gel, and it often doesn't give a very comprehensive view of the effect of the emissions. And that's where the simulation can really help us in predicting accurately these emissions and in passing the certification tests in the first attempt. And finally, in the world of connectivity, an important consideration is always this balance between performance, because we are focusing on 5G, a good communication link, and the safety of the operator and other electronic equipment. Multidisciplinary simulation, which my colleague is going to talk a little bit about in the next few slides, combined with probably design of experiments framework, is key to understanding the compromises and evaluating design alternatives in a short amount of time. So these are some of the business objectives where simulation can really help us avoid costly early design failures and help speed up go-to-market. Now I'd like to hand it over to my colleague Chris, who will show you how the electromagnetic simulation using CST STUDIO Suite works.
Okay, thank you, Mahesh. So far, Mahesh and Lewis have spoken in very general terms about 5G and how simulation is important, and I want to bring all this a bit closer to sort of the actual day-to-day work that engineers will have to face. And I want to introduce CST STUDIO Suite as a tool to use. So CST STUDIO Suite is a standalone application that has a very rich history, 30 plus years of use in every industry imaginable and for all sorts of applications. Basically, one way I like to always frame it is if your product carries a current, if there's a current running through your product, you're going to need electromagnetic simulation, no matter whether it's a phone, a car, or anything else. And one thing that sets CST apart is the fact that it's a complete technology. So we have close to 24 different solvers which are included in the base package for all sorts of different applications. And depending on the frequency range that you're working in or the problem you're trying to solve, there isn't one solver that solves every problem. You'll need different tools for different kinds of applications. So we have solvers for low frequency applications like sensors and electric motors. We also have sort of more esoteric solvers for particle simulation. And more specifically related to the topic at hand today, CST is widely used for designing and simulating antennas, the electronics, the PCBs, and also looking at the EMC-EMI compliance that Mahesh was alluding to earlier. Now, because we're talking about 5G and we've already mentioned antennas, you cannot have 5G-enabled devices without antennas. And actually 5G isn't just a new standard with faster speeds, higher capacity, etc. 5G, because it's working at a very high frequency compared to previous wireless standards, introduces a whole host of new novel engineering challenges that we have no solution for because we've never really had to deal with these kinds of problems in the past. So this is especially problematic with smart devices where we're trying to cram an awful lot of data and an awful lot of devices into a small package. And a modern 5G phone doesn't only have to work with 5G, it also still has to connect with older standards. And you'll probably want to take your smartphone on vacation. So while your phone might be bought in North America, you'll want it to work if you go on vacation in Asia or in Europe. And all these different areas, they all use different frequency bands for their wireless communication. So your phone needs to be able to communicate with a very wide range of frequencies, meaning that within a modern smartphone, we don't just have one antenna, we don't just have two antennas, we have close to 12 antennas for different frequencies that all need to work individually, but more importantly, they also have to work sort of in close conjunction with one another. They can't disturb or interfere with one another. Now, beyond the antennas that obviously need to be engineered and solved, the antennas also need to be connected. Now, if we consider a car or an airplane, obviously we have a wire harness that connects all these devices. Within smart electronics these days, we don't have cables, we don't have wires. Everything's connected through the PCBs, so we really need to be able to bring in that data from wherever it was produced. And CST as a tool is very open. We can import CAD and ECAD data from any tool imaginable in order to then perform 1D and 3D electromagnetic simulation on them, in order to easily visualize things that we, even if we wanted to, we can't look at if we just rely on measurement. Or even if we could, it's incredibly time-consuming and expensive to do these kind of analyses in measurement. Not to mention that we obviously always, when we talk about simulation, we want to introduce simulation as early in the design process as possible in order to identify problems early before they appear, before even the first prototype is made, because the later a problem crops up, obviously, the more expensive it is to fix said problem. And now I'm aware that most people on the call are existing SolidWorks customers, so I want to sort of highlight the fact that CST plays incredibly well with SolidWorks. So there's a fully bi-directional coupling with SolidWorks for parametric models. So you can imagine you're building your assembly in SolidWorks, and there's probably going to be 1,000,001 things and items that you can and have parametrized. And we want to be able to tune these parameters in the electromagnetic simulation. So if we import that SolidWorks model into CST Studio Suite, we can choose which parameters we want to import with the model, and then we can directly change those values within CST to run things like design of experiments or sensitivity studies to determine if certain parameters change, maybe even just in terms of manufacturing tolerances, what's the effect going to be on our electromagnetic performance? And even manufacturing tolerances, which tend to be very fine, can have a huge impact on the electromagnetic performance, especially if we go to higher frequencies of millimeter 5G waveguide simulation. So sort of to wrap up why electromagnetic simulation is important and crucial to any kind of product development, and why CST is really the market leader in this space. We have a very diverse solver technology to address all sorts of problems. We have solvers for low frequency, high frequency. We have thermal solvers to look at that coupling, the multi-physics between things heating up and potential effects on electromagnetics performance. We can easily mesh imported geometry from wherever it might be, SolidWorks or other CAD programs, and we can even import meshes from tools themselves. If we have a structural simulation where we already have meshes, we can bring those in. And all this optimization and parameter sweeps is directly pre-baked in the tool. It's incredibly easy to set up a design of experiment or an optimization run, and everything works across the entire frequency spectrum, from low frequency static to high frequency terahertz optical wavelengths. And now, just to give you an idea what the tool actually looks like, we have a short video that we're going to show where we can see the tool in action, just to give you an idea of what it looks like. And especially as your SolidWorks customers, I always like to compare CST Studio Suite with SolidWorks insofar as the users of CST really love using CST because it's very user-friendly, the UI is very intuitive, and it's the same feedback we always hear from our SolidWorks customers. What we see here is we have a smart device, sort of a smart infotainment device that was built in SolidWorks, and we are able to import that. What we're going to do now is we're going to import the geometry of this smart speaker from SolidWorks into CST Studio Suite, and in addition to that we're also importing 2 antennas that we want to place within this assembly. And one of the cool features of CST Studio Suite is the fact that we can define these anchor points to automatically place and orient antennas within the assembly, which makes it really easy to cycle between different configurations of where we want to place those antennas. As a next step, we would then define the simulation tasks, which would be looking at different aspects of the simulation, defining simulation runs for different frequency ranges, and these can then run successively to look at the performance. And then we can visualize the simulation results, the 1D plots like the scattering parameters, or in this case the far field plots, to really understand how the system performs for the different antennas and different configurations. And as a last step, we then want to store the model with all those simulation results and configurations directly in the 3D Experience platform using our PowerBuy connector in order to have all that data stored and centrally managed. And if we do that for the different configurations, we can easily compare the different configurations and results in order to then make a determination which configuration we want to move forward with into production. And just to wrap up the more technical part of the presentation, obviously in any complex device that we're manufacturing or designing, we're not exclusively looking at the electromagnetics performance. We have to consider the thermal behavior of our system. We have to consider the structural behavior of our system. And all these different disciplines, they don't function in isolation. Any change that we make to the structure of our device because we need to make it more robust is going to have an impact on the thermal behavior and on the electromagnetics behavior. And we have very, very cool and capable tools, in this case Process Composer, to really help build these multidisciplinary simulation processes in order to analyze how these different disciplines work together and what parameters and KPIs are really key to unlocking peak performance of our system. And with that, I would like to turn back to John to wrap up this presentation. Thank you.
All right, thanks a lot, Chris. I appreciate it. That was awesome. And wrapping up, right? What I really wanted to do is kind of just talk with you guys about, what are the big key takeaways. Now, obviously, there's a lot that we covered today, but one of the biggest ones is 5G unlocks huge potential when it comes to innovation and design. That's pretty obvious, right? But with it comes a whole new set of challenges, specifically things like safety and compliance, right? And as we can see, these things aren't easily simulated in terms of a prototype, and in a lot of cases, it's not practical to simulate some of these things with physical prototypes all the time. So, a realistic simulation tool like CST STUDIO SUITE is paramount to the success when entering this new realm where 5G components are going to be more and more popular and actually required to compete in the market. So with that, I wanted to thank all you for coming. If you have any questions about CST or advanced simulation in general, reach out to your account manager for assistance, or if you have any questions specific to a condition that you're working with right now, or if you'd like to set up a consultation with one of our product experts here, we're happy to get on the phone and kind of dig into the weeds with you. And also, we're very happy to set up a demonstration as well. And with that, thank you very much, and have a great day.